Hi there, this is a statistics video checking out how do we compare data sets using different plots. We're going to have a look at stem and leaf plots and box and whisker plots and see how they can help us compare data sets. Here's a double stem and leaf plot. These are two classes, an A class and a B class, who are sitting for the same test, and these are their test scores. With the stem and leaf plot here, we can see that these are the tens columns really, so these scores are 52, 52, 55, 57, etc. And over here in the B class we've got 83, 84, 85. So they're the scores there on the double stem and leaf plot. Gets us to be able to compare the classes on two tests. Well, one test, two classes. So some of the statistical comparisons we could make are ones to do with the mode. We can overall get a modal score, or the mode score, the score that occurs the most, and you can see that there are 3 75s in class B and no other score occurs 3 times. So 75 is the score that occurs the most, so we'd call that the modal score overall. The range, which is a measure of the spread of scores, we can do a range for class A, and the range is the highest score minus the lowest score. So we've got 73, take away 52. 73 minus 52 there will give us our 21. So that's our range of scores of 21 in class A. We could do a range for class B. The highest score is 94 and the lowest score is 63. 94 minus 63 gives us a range of 31. So even on that basis, we could say that the scores in the B class are more spread out, and we could say that the scores in the A class are perhaps more consistent, even though they're consistently lower. So we could say, yeah, the spread of scores in class B is greater. The range overall is 42. The highest score in the two classes was 94, and the lowest score in the two classes was 52. So 94 minus 52 gives us a range overall of 42 marks. The mean, or the average of class A, would be found by calculating 52 plus 52 plus 55 plus 57 plus 58 all the way up to 73. Get a total of those scores and then divide by how many scores we've got. Now we've got 11 scores here. It's important to count the scores over here on one side or the other and not double count the scores that are part of the stem there. So that would be double counting them. There are 11 scores in class A and 11 scores in the B class as well. So we'd add that up and divide by 11 on our calculator. 61 is the class average for class A. We could do that for class B as well. Add 63 plus 75 plus 75 plus 75 right up to 94 and divide by 11 there. And you can see you can make a comparison statement there, or a conclusion, that the class average for class B is over 20 marks higher than the class average for class A. So we could make some statements about that. We could also get the mean overall. We could add up all those scores and divide by 22 and get the fact that the mean overall between the two classes was 71-ish there. Alright, so the shape of class B. Occasionally we're asked for the shape of the data. Now what this allows us to do, the stem and leaf plots, is to sort of draw a little bit of a shape around it. And if we drew that on its side, we would get a bit of a tail there, and more of the scores are over here. Now the way we name the shape here is we have a look at the tail, and I like to think of the number line there, and we'd call, because the tail bit is down the negative end, we call that negatively skewed. That's the way I remember it anyway. So it's slightly negatively skewed, this set of data there, and we can tell that by kind of drawing around the shape and thinking of what it would look like if it was sitting flat. I suppose you could turn your whole book or your computer around, but still. So we could get a bit of an idea of the shape sometimes. Alright, which class performed better? Now I think it's pretty clear that just a quick glance would tell you that the B class had higher scores. Really these are in the 50s down here, and these are in the 90s here, so you can see that there's lots of scores up in the 80s and 90s for class B, and the highest score in class A was 73, so I don't know what happened to them, but still. So which class performed better? Now in tests they often ask you to justify your answer, so we could say a lot of different ways how we could tell whether the class B performed better. We could say there's a higher mean, so the mean for class B was 20 marks higher, as we said earlier in the video. We could also have a look at the higher maximum mark. We could say that the highest mark in Class B was 94, where the highest mark in Class A was 73. And we could say a lot of things about that. We could almost make a statement, except for this 63 here, we could almost make a statement that 10 out of the 11 students in Class B beat the highest score in Class A. So really it was pretty clear that Class B was the class that performed better in that comparison. So having a look at that, I just hope that helps you have a think about how we might go about comparing data sets. We could comment on the range, the mean, the mode. We could look for the median if we want to. Depends on what they ask in the question. But you should be able to justify and answer. The data they give you in these sorts of questions is fairly obvious, that one's bigger than the other or whatever. So have a good stare at the double stem and leaf and make your comparisons as I've modelled for you there. Okay, now box and whisker plot, that's the basic shape for it. Let's remind ourselves of the items that make up a box and whisker plot. We have a lowest extreme down there. We have a Q1, which is like the quarter point if we put all the scores in order, the lower quartile. That middle line is the median or the middle score, or the average of the two middle scores, depending on how many scores we've got there. We've got the Q3 or the upper quartile. It's like the three-quarter way score if we put them all in order. And the last bit is the upper extreme. So that's what makes up a box and whisker plot. Now, another way of saying those, if we wrote down those 5 numbers, we would call that a 5-number summary or a 5-figure summary. That kind of tells us a lot about the spread of the data. If we just had 5 numbers, those 5 numbers for each of the data, we could tell how spread out things are and whereabouts on a graph these numbers would be. So they're called 5-number summary or 5-figure summary. Tells us a lot. Okay, now one idea here is that each section of our box and whisker plot it makes up approximately 25% of the data. So 25% of the scores should lie between the lower extreme and Q1, and another 25% of the scores should lie in the next section there, between the lower quartile and the median. And of course the median is supposed to be the score or scores above which there's 50% of the scores altogether, and below which there's 50% of the scores altogether. So one of the definitions of the median is the line between the two 50% of the scores, right in the middle there. There's 25% of the scores that are supposed to be between the median and the Q3, and another 25% of the scores in the upper section there between the upper quartile and the upper extreme. Okay, there's Class A and Class B here. Let's have a look. These are two classes sitting for the same maths test out of 40 marks. And I'll put them all in order there to make it nice and clear, and it's also convenient that there's the same number of scores in each class there. But let's have a look. We can pick the lower extreme for each. We can pick the upper extreme for each. If we count carefully, we can pick the median, which is halfway between a couple of scores in the middle there. And then we can pick the lower quartile, which is again halfway between a set of scores there, and the upper quartile, lower quartile Q1 and upper quartile Q3. So we can figure out the numbers there. We can have a 5-figure summary. Now let's go through the 5-figure summary for Class A here. We've got the lower extreme. We've got Q1. Now I've put 27 there, which is halfway between the 26 and the 28. That's how we got that 27. The median is halfway between 30 and 32, so we'd add them together and divide by 2 and get 31 there. Once again, there's a halfway between here, between 34 and 36 is 35 for that Q3, and the upper extreme is your 37. So that's how we got our 5-figure summary there, 5-number summary. So do a similar thing for Class B, just to show you. There's our 5-number summary. Our lower extreme is just the 18 there. 22 came about by averaging 22 and 22 together, which is no surprise. We've got... Sorry, before we get down to the grid here, we've got 25 here, which is halfway between our 24 and our 26 for the median. Our upper quartile, our Q3, is halfway between 28 and 30, or add them together and divide by 2, and our upper extreme is 32. So once we've got those 5-figure summaries, those are the numbers that go on our box and whisker plots, and if we carefully put the Class A onto our grid here, and Class B, we can do some comparing quite nicely. Now we have a look at the lowest score we've got is 18, and the highest score we've got between the two classes is 37, so we want a grid that will take into account all those numbers. So our A class here, let me double check with you the plots there. We're really plotting these 5 number summaries. So the lowest score is 25, so that's where that mark will go. 25, that's supposed to be a straight line, but still. We have 27. I'll try and do a straight line now. 27's there. The 31 is should be lined up there. 35 is that bit there, the Q3, and 37 is our highest score. It looks messy, that, doesn't it? Let's flick over. Okay, we got class B, and so we're trying to process these numbers on. 18 lines up nicely. 22 is our Q1 for class B. 25 is our median. 29 is our Q3, and 32 is our highest score. Okay, so that's how we plot the box and whiskers, and if we do it for 2 classes, we can then start making some big comparisons between the two. Let's compare. Alright, they're the 2 classes. As we concluded in the from just a quick glance here, I think the class A did better in this particular case. Now let's compare the items here, the highest scores. Now Class A's highest score was 37. We could piece this together here. Class B's highest score was 32, so that's a point of comparison there. So we're just looking at that point there and that point there. Now we could also compare lowest scores. So the lowest score in Class A was 25. The lowest score in Class B was 18, so we could compile that there. And we could make a statement or a conclusion about that if we wanted to. The medians would look here for our median there, 31 for Class A. Could make a table out of this. And the median for Class B was 25. So we'd piece all that together and make comments if we wanted to. The shapes of each of these. Now, I'm here to tell you that it looks pretty symmetrical, this here. So there's not much to say. I suppose you could say symmetrical. I won't write the whole word. I can spell it, trust me. It's pretty symmetrical. The distance is there and there. And this one's pretty symmetrical too. This tail's a bit longer there. So we might, yeah, it's a question mark there. We could possibly suggest that the tail's a little bit longer there, so it's negatively skewed. But anyway, some other graphs might be a bit more obvious than that. So we could make a comment about the shapes if we wanted to, and the ranges definitely can be compared. 37, the highest score of 37 minus 25 there has a range of 12 for Class A. Highest score for Class B, 32 minus 18. I reckon that's a range of 14 if my calculations serve me correctly. So you could comment on the spread of the scores there, although they look pretty similar in this case. And you could also talk about the percentages. Now, we said that there's 25% in each chunk. 25% here, 25% here, 25% here, 25% here. So you can make some bold statements that say, perhaps, if you compare this bit here, you got the lowest score for Class A lining up with the median of Class B. So what's that saying is really all of Class A's scores are at least the same or above as the top 50% only of Class B. So all of the scores in Class A are at least as good as the median for Class B. So that's a pretty good statement you could make there. So you could say something along the lines of 100% of Class A scores are greater than or equal to the top 50% of Class B scores, or something along those lines. So we can, if we remember that there's 25% in each chunk here, you could say something like the bottom 50% of Class B, 25% being there and 25% being there, the bottom 50% of Class B were lower or equal to the lowest score in Class A. So it's pretty clear that Class A did a lot better than Class B in this test, and you've got a lot of the statistics to back yourself up in a comparison of high scores, low scores, medians, etc., and looking at the percentages. So I just wanted to model for you how we might think about comparing data sets using the plots. We had a look at the a double stem and leaf plot. for one test, and this is a data comparison based on the box and whisker plots in this one. So I hope that shows you how we might compare using those two sorts of statistical plots. And all the best for that. Have a look at it again if you're not sure. Just wanted to chat the way through that. peterblakemaths.com. We'll see you next time for another item. Thanks. Bye.